All right, so if you're trying to find life on Mars, where do you even begin? I mean, you'd probably think the answer involves these massive telescopes, right? Or maybe some far-flung spacecraft. But believe it or not, the search actually starts much, much closer to home. We're talking about the inside of a lava field from a volcano that just erupted in Iceland. Yeah, Iceland. So let's get into it. This is one of the biggest questions out there, the one that really drives so much of our science and exploration. It's why we send these incredible rovers to crawl across alien landscapes and why we push our tech to the absolute brink. But think about it. How on earth do you practice for a mission that's millions and millions of miles away? Well, it turns out the best way to get ready for exploring an alien world is to find one right here on Earth. Isn't that wild? The secret isn't just floating out there in the stars. Nope, it's actually hidden away in some of the most extreme, most Mars-like places you can imagine, right here on our home turf. So let's talk about Mars for a second. For ages, it's been our #1 suspect in the hunt for alien life. Why? Because all the evidence points to a distant past where it was way warmer and wetter, maybe with rivers and lakes, the kind of place where life could have gotten a foothold. And that's exactly why our rovers, like Curiosity and Perseverance, are up there right now, scouring the surface for any little clue, what scientists call biosignatures, that something was once alive. And that brings us right back to Iceland. Seriously, some of its volcanic landscapes are so barren and, well, so alien, they're pretty much the perfect stunt double for Mars. This is what scientists have a cool name for, a planetary analog site. And these places are absolutely critical for figuring out how to explore the rest of our solar system. Okay, so what exactly is a planetary analog? Let's break it down. Basically, it's just a spot on Earth that acts like a stand-in for another planet. Think of it like a full-blown rehearsal space. It's where you can test out all your fancy new equipment, figure out the best strategies for exploring, and study the kinds of geology and biology you think you'll find on Mars, all without the hassle of a 6-month rocket ride. And when you put the two side by side, the similarities are just striking. Look, in Iceland, you've got this brand spanking new landscape, literally sterilized by a volcano, a total blank slate. Then you look at Mars, and you've got these ancient volcanic plains that have been frozen and barren for billions of years. But here's the thing. The fundamental question is exactly the same for both. Can life start here from scratch? Or, in the case of Mars, could it have started here in the past? Okay, so what does NASA do? They send a team of scientists right into the belly of the beast, into this incredible alien landscape. This mission, led by Dr. Amanda Stockton, is so much more than just a field trip to look at rocks. No way. It is a full-on, meticulously planned simulation of a mission to another planet. And their objectives? They are laser-focused. First up, they want to know how quickly life, we're talking tiny microbes here, can come back from a total wipeout. I mean, the lava just erased everything. Understanding that gives us a roadmap for what to look for on Mars. They're also figuring out the best ways to actually do the exploration, kind of like writing the official playbook for future astronauts. And, of course, they're doing the exact same kind of science our rovers are doing millions of miles away. So their process is super systematic, just like it has to be on Mars. First, they send up drones to get the lay of the land, creating these incredibly detailed maps to pinpoint the best places to investigate. Once they have their targets, the team goes in on the ground to carefully collect samples of volcanic rock. And finally, they bring those samples to a mobile lab right there in the field to start hunting for any tiny, tiny signs of life. And this is where the whole picture just snaps into focus. This entire mission, everything they're doing in Iceland, is really just one big dress rehearsal. It's a practice run for how we operate those amazing multi-billion-dollar rovers like Curiosity and Perseverance when they're a whole planet away and we can't just go fix something if it goes wrong. I mean, check out the one-to-one parallels here. It's incredible. The drones they use to map the lava field in Iceland, that's how we practice using our orbiters to map the surface of Mars. The geologists on the ground, carefully choosing which rocks to sample, they're literally acting out the decision-making process for the rover's robotic arm. And that field lab they use for analysis, it's a direct stand-in for the suite of advanced scientific instruments that are packed inside the rovers. So you might be wondering, why go through all this trouble? Why fly all the way to Iceland to pretend you're on Mars? It's because everything we learned in these harsh, forgotten corners of our own planet gives us the knowledge we need to search for life somewhere else. Earth is and always will be our ultimate cheat sheet for exploring the cosmos. Think about it. To find life out there, we first have to understand the absolute limits of life right here. By seeing how life can claw its way back, how it can survive and even thrive in a place like a brand new lava field, we're basically rewriting life's rulebook. We're figuring out what's truly possible. And that knowledge is what tells us exactly what kind of clues to look for when we're sifting through the red dust of Mars. Which, of course, leaves us with one last really big question. If life is so tough, so stubborn, that it can find a way to come back to a place that was literally molten rock just a short time ago, a completely sterile environment, well, it just makes you wonder, doesn't it? Where else out there, in all those seemingly empty and desolate corners of the universe, might it just be hiding, waiting for us to find it?